Hey, welcome to NASA Edge.
An inside and outside look
at all things NASA.
Oh, that's gonna leave a mark.
Our first guest, Rob Mueller, head judge for Lunabotics.
Plus, the NASA Edge team explains the competition.
The 2011 Lunabotics Mining Competition begins right here in the lunar pits. This is a location where all the teams from around the world come, unpack their excavators, pull them out, take them through diagnostic tests to prepare themselves to go into the Lunarena to battle to see who could get the most regolith into the bins. But before they leave the lunar pits, they have to get their excavators weighed and then head on over to communications, where Blair is stationed right now to give us more details.
Thanks, Franklin. We're here with the comm team for the second part of the checkout for all the competitors. Now, I understand that the comm checkout is a very important part of this process. So, Mark, could you tell us what happens at a comm checkout for our competitors?
Well, what we do is make sure they're configured correctly to go into the tent and not interfere with the other robot while they're competing.
Now, have things gone well so far? All the teams have checked out?
Yeah, all teams have checked out. A couple hiccups. We helped them get through a couple things, but they were ready to go.
Okay, very good. Now, another part of this is to make sure communication is fair throughout the entire competition. And I understand, Mike, you have a device that checks that out. So what exactly is this here?
Yeah, this is a Wi-Fi tester, and this allows me to see anything that's transmitting in Wi-Fi, and it allows me to make sure there's no interference and everyone's doing what they're supposed to.
Now, what is this not doing what's supposed to? Do you mean cheating, or do you just mean incidental communication?
I mean, incidental. Turn on when they're not supposed to be, and then they're interfering with the actual competition.
And now, so you're telling me that this device will tell you if someone opens up a wireless network in the vicinity that shouldn't?
Yes, and allows me to hunt them down and find them.
So you're the guy that's usually parked somewhere near my house interfering with my Wi-Fi network?
Yes, absolutely. In a black van.
Well, that's uncomfortable, but clearly they're doing their work as the comm team here. And the competitors, when they're done and checked out with these guys, they move to the Lunarena, where Chris will tell us what happens next. Where are you guys?
Hey, thanks, Blair. We're here at the Lunarena, the final staging area for the competition. All the teams will come to this point with their excavators. They're going to suit up. If the students get inside the Lunarena but not in the pit, they have to wear goggles and a mask. If they're going to be in the pit area, they also have to wear gloves and a bunny suit. Safety is the utmost important in this competition. So once the teams get their excavators inside the Lunarena, they have 10 minutes to check their systems out, make sure everything's ready to go. And now their excavators can be placed inside the pit. Then they have 15 minutes to excavate as much lunar simulant as possible. Now, the competition is wild. We have 36 teams competing. We'll see how they do today.
Great to have you on the show this morning. We have actually been fielding several rulings questions. We'd love to ask them, but tell us, how's the competition going so far?
So far, this is a fantastic event. It's twice as big as it was last year. We have 36 teams here. We have Canadians here, Bangladesh, India, Colombia. It's really just been a fantastic event so far.
Take us through this whole judging process. How many judges do you have on your team?
We have 14 judges. They come from all over the country. They're all volunteers, but they represent various aerospace companies and various NASA centers. And they believe in what we're doing. They believe in human and robotic exploration of the solar system. And we're very lucky to have them here.
So the past couple of days, we've been spending a lot of time with the teams. And we do have some questions on the rulings.
Absolutely.
And I think the biggest one that I think Blair and I have at this point is actually in the lunar pit. We noticed before they start, they place the rovers in different positions. Some are parallel with the hopper, some are perpendicular with the hopper. Is there a reason for that, or they get to choose where they want to be positioned?
Well, we have a rule that talks about random placement of the Lunabot at the beginning of the competition. So we have dice. They're four-sided dice, and we roll them. One roll is for the position. We have 4 quadrants. And so the robot could be in one of 4 quadrants, so the starting position is random, and this makes it a little bit more challenging for the driver. And the second roll of the dice is for the direction. So we have a north, south, east, west direction, and so there are two components to the randomness, and that is just designed to make it a little bit more unpredictable at the beginning.
Right. And of course, it is important that the teams know these rules, so they obviously are prepared if they're facing a wall and need to back out or things like that. That would be part of what they need to be prepared for.
Yeah, well, we have these obstacles, okay? So we have three areas in the Lunarena. One is the mining area, one is the obstacle course, and then the third one is the area where you start and where you deposit the regolith into the collector. So it's designed to simulate a lunar mission. Now, obviously, we can't make a huge box that's miles long, but we tried to do the best we could in the space we had. So we think we'll travel about 100 meters on the moon through an obstacle course. So obviously the moon is random, unpredictable. There's rocks, there's craters. So that's what we did. We have two craters that are 30 centimeters in diameter, and we have rocks which are 20 centimeters in diameter with 3 rocks and 2 craters. You have to navigate the obstacle course. The obstacle course does not change from team to team. It's the same for all teams, so we have a level playing field, and they have to negotiate that obstacle course as if they were on a traverse on the moon. They go to the mining area, which we'll probably have on the moon too, because it's an incredibly dusty place. So you would never want to have your mining area next to your habitat.
Right.
So in that case, you'd be spraying dust all over your habitat.
Especially if you're Laurentia University, who kicked up quite a bit of dust yesterday.
I like to call that machine the Beast.
Very appropriate.
And just to remind him, it was 237.6 kilograms. Up next, Franklin talks to the teams in the lunar pits about their excavators.
And I happened to get an interview with engineer and vice president of Caterpillar, Tana Utley.
Caterpillar actually sponsored the Lunabotics Mining Competition.
Right. Maybe Tana Utley is vice president first, then an engineer.
I'm here with Jacob from Embry-Riddle University, and he's going to tell me a little bit about Larry. What does Larry stand for?
Larry is Lunar All-Terrain Regolith Excavator. A Larry is a 4-wheel independent suspension robot with a bucket drum device on the front.
You got a pretty nice paint job. You know, I kind of looked at it and said, looks like the frame of a NASCAR. How'd you come up with that design?
Well, our school has a jet dragster project where we are outfitting a normal dragster car with the jet engine, and we're learning how to use chromoly tubes, notching, welding, bending, and we took all of those skills that we learned there and applied it to this chassis. So now we have this robot that's kind of modeled after a dune buggy.
It looks like you brought the whole engineering department here.
Yeah, we've got about 15 people with us today. Of the 25 people in our club, 15 were able to come, so it's a pretty good turnout.
So this is not a class project. Everybody here volunteered to work on this project?
Well, you see, we have 2 classes. We've got a senior design class and then a multidisciplinary design class that our advisor, Jim Heisey, teaches. So we started a club last fall, and we're now up to 25 group members from about 6 when we started. And the club and the classes work together. The classes do a lot of the design work, and the club does a lot of the fabrication. So, yeah, most of it's all on our own. A lot of the design's done in the class, but most of the fabrication is done by the club.
Now, you know that regolith is very, very, very fine. What did you use to test your excavator back in Colorado?
Cement dust, which is also pretty fine, but it's actually a bit more clumpy than the stuff out here, so.
You haven't been in the pit yet?
No, we have not. We'll be up next.
Nervous?
A little bit, but we're excited. We're all very excited.
It's actually 12 people on your team, and you 2 guys are the only ones here. Why is that?
Well, we made sure to get all our bugs worked out before we came here. And right now, we're pretty bored right now. And that's a good thing because we don't have anything going wrong.
Have you been in the pit yet?
Yeah, we've been in the pit twice, actually.
Did you gather any regolith?
Yeah, actually, the first time we gathered 154 kilograms, and the second time we got 148 kilograms. And we're taking it kind of easy, and hopefully we can get a little bit more when we actually go in the pit.
At 150 and 148, you guys sound like front runners.
From what we've heard, no one's really come close so far, but you know, it's still early. Anything can happen. A team could shoot out of nowhere, or something could go wrong with our machine. So we're gonna just take it easy with it right now, and hopefully come Thursday or Friday or Saturday, it'll be ready to go.
So you guys have like a second module here. What's that all about?
It's a percussive digger system, and we made our whole system modular so that we can swap them out, and in future years we don't have to rebuild everything, we just add on to it. And this system is something they were describing last year. It actually helps you penetrate the regolith because it's really dense. So it's basically like a shovel strapped to a jackhammer. and that lets you just cut into the dirt, and it should just help us scoop up a lot more that way.
So you're looking beyond 2011 for the 2012 competition.
That's exactly right.
Wow, when I first walked in, I saw you guys were sitting here, kind of, somebody was like asleep back there. You guys were like done. Why aren't you working like everybody else in the room?
We're definitely going for tortoise and hare. We're the tortoise. We've been working on this since September, and it's May now, and we've been working steadily along the way to make sure everything was in place, so that once we get to the competition, we just have to sit here, assemble our robot, and be ready to go. No problems.
So right now you're up, running, comms working, the excavator's working. You're just ready to get in the pit.
Exactly. We're ready to go.
Hey, we'll see how it goes.
All right.
Thanks a lot, Jacob.
Thank you.
I'm here with Tana Utley of Caterpillar. She's the Vice President and Chief Technology Officer. And I understand that we're at the Lunabotics Mining Competition, and you guys have been very instrumental in making that happen. How did you get involved in the competition?
Well, actually, being involved in the competition is just an outgrowth of our relationship with NASA. We're doing some joint development with NASA today. We're working on remote control for our skid steer loaders. In fact, you see one of our skid steer loaders out here. We'd like to be able to operate that remotely, and oddly enough, NASA had the very same interest. They'd like to be able to remote control, except instead of from one station to a machine not so far away, they want to do it, to some far-flung planet.
Yeah, they tend to want to do that.
Yeah, and they don't call it dirt either. They call it regolith or something like that. But other than that, we have a lot in common, I think.
Well, what do you think of the field you've seen of the robots here at the competition?
I think it's fascinating. I'm a mechanical engineer by nature and training, so I like to look at the different mechanical designs of the robots, and you really see a couple different design philosophies. You see some folks that have the sprockets, the bucket kind of style, and others have like our MTL. It's going to be interesting to see which one wins.
Now, there's an obvious connection here. Are you, as you're looking at these robots and these teams, are you recruiting in any way?
We really have a couple of objectives for being here. One of them is working on the CAT brand. We've got a wonderful brand, and there's a lot of technology in our products, so we like being associated with NASA. The students that are going to be the engineers of the future, when they think about the CAT brand, we want them to think of high-tech, advanced kind of work we do, because we need those kinds of folks to come to our company. We have some great ones, don't get me wrong, but we'd like to have even more.
Well, if you're going to continue to do this for the long term, you got to think about the next generation.
Oh, you absolutely do. And one of the things that impresses me so much with the young people and just coming out of school is how quickly they learn and how they can come right into a corporate environment with those skills they have, especially having been involved in some kind of hands-on program like this, and be able to apply those skills and help us make better Caterpillar machines.
What do you see for the future of competitions like this? Is Caterpillar, is this something you're committed to long-term, or what do you see the future benefits of a competition like this?
Well, first of all, I'd like to comment just on the value to the students and then the continual learning that happens. Last year, I understand we didn't have many vehicles, actually any maybe that really completed the course, which you'd call successfully. This time, the first two vehicles right out of the chute were successful. So year over year, it's going to be fun to watch it evolve and see the learning transferred from one generation of students to the next. And, when Caterpillar gets involved in something like that, we demonstrate our commitment. We're not a once and gone. I expect we're going to be back here next year rooting it on. In fact, I was thinking today as I was walking across the yard here and seeing our tent, sponsor tent, one of these days we're going to have a lot more sponsors out here, but I'm going to look at the CAT tent and know that we were the first tent here.
A prominent footprint by the Caterpillar folks. Thanks so much. Appreciate it. You're watching NASA Edge, an inside and outside look at all things NASA. Looking out for the future generation engineers. Thanks so much.
You're welcome. Thank you.
And now, we like to highlight NASA Edge's very own NASA Caterpillar promo.
I can't do this. I always get nervous when you bring this up.
Just relax. We'll roll the promo, hear from more students, Lunarena University, and if you recover, you can announce the winners.
That's impressive. You're operating the MTL remotely?
That's correct. That's what we're demonstrating today.
What's up with the yellow box?
This is a safety E-stop. I hit this red button, everything shuts down quickly.
That's pretty cool. I gotta get me one of those.
Everybody's at lunch. Time for a little experimental joyride.
What are you talking about?
Turn and burn.
It's like NASA Edge has a new partner.
I'm not hurt, I just can't move.
Yeah, we're gonna have to reboot him.
Does that hurt?
So you've actually already gone, Zach, and you had a wheel issue. Can you explain that?
Yeah, so our track system is kind of inspired by a design we saw at Vermeer Corporation, and we designed that last fall in our senior design class. And we had it all together and functioning well. Tested on the beach earlier this week, and it came down to a little Loctite on a screw. One of our screws backed out, and the track system fell apart. So
You say you tested on the beach?
yeah, we tested on the beach.
You didn't put it in the water, did you?
We wanted to, but we restrained ourselves.
Maybe that's where the wheel issue went.
Yeah, that might have been.
That's
So
right.
a little seashell or something maybe.
Doing donuts on the beach.
Yeah.
That's good.
Now,
Yep.
Shibli, you're from Bangladesh.
That's
from
right.
Brack University,
That's right.
but you haven't gone yet.
Right. So we would be going this afternoon, just within an hour or two, and we're very excited. We did have a few issues during the practice, and we hope we have solved this issue.
You nervous?
Not really, but we're very excited to try it out.
Now, Shibli, you did have a practice session. Were you able to collect any regolith during your practice session?
During our practice session, we could get out in the mining zone and collect, but unfortunately, I got stuck in the boulders, so we couldn't really come back to deposit, but the excavation system worked pretty well.
Oh, nice. Now, are you the driver for your team?
I will be with the driver, so sometimes I might be driving and operating some of the components.
And how do you decide who drives for the team?
For our team, we took the guy who is expert in video games. So, and we are using joysticks to control the whole robot. The joystick is connected with the laptop, and we can also control it with the laptop. So simultaneously, two persons can actually control the whole robot. The redundancy is for our safety, so that if something fails, that we can recover.
Now, Zach, do you have any advice for Shibli now that you've already gone and he has it?
I think one of the biggest things that we've discussed since our competition attempt was to come back next year with an optimized robot and not a redesigned robot from the ground up.
Right.
Just optimizing the systems we currently have and spending a lot of time testing the robot that we have next fall.
That's actually bringing up a good point, because you got to make that decision. I mean, do you come back with a completely different design? Because I mean, at the tendency age, I see a lot of you guys going around to the different pits and taking pictures of other teams' excavators. You're probably wondering in your mind, is that one better than mine? Is that the design to go to? But that's a good point about you sticking to your design, just optimizing it, and then coming back strong next year.
And of course, Shibli, you had some challenges getting materials for your robot, and that actually dictated how you design, correct?
That is true. So when we were designing, we had to consider what is available near us, because a lot of things are not there, and then we had to think about shipping it here. We had to think about how we were going to dismantle it and distribute the weight in our luggage so that we can bring it in the flight. So we actually did a pretty good job, and it's there, and we came on the first day on 23rd, and we assembled it within 2 hours.
That's got to be pretty amazing, checking a Lunabotics mining robot.
So you had a lot of creativity in finding the parts for your excavator.
That's right. So when we started the design, we didn't really know what's available. And the most interesting thing is that in our team, we have no mechanical engineering students. So we are all electrical engineers, and just me who's computer science student.
Okay.
So we didn't really know how to proceed, but we made our design. We figured out that there's nothing available near us so we can use. So we redesigned it, and this is actually the 7th design that we have. We had a lot of challenges, but we figured things out. When we were testing in our country, it worked perfectly.
What would be the biggest thing that you've gained from this experience here at Lunabotics?
Oh boy. I think just for all the engineering students to actually take something from design concept to fabrication, and then also get to test it, and not only just test it, but test it in the lunar simulant, that's completely different from sand. Just getting to see that all the way through the process, I think is just essential for almost any engineering student. And unfortunately, not many engineering students get the opportunity to come to a competition like this and
and be able to do those things.
So we are working in a physical environment, and over here to get an experience, you actually need a first-hand experience, which we are getting it here now. And it was really great to learn from all these schools, because we see that someone who have a similar design, that similar principle that we had in our robot, and they actually excavated the most amount of regolith. So we are pretty confident that our design is good, and we just need to optimize it.
Do you think anyone's going to top 237.6 kilograms?
We were pretty impressed to see that. Yeah, that's pretty amazing.
That was a beast, wasn't it?
Yeah.
And it's pretty unpredictable.
That's right.
We never knew in the practice who's going to top 200.
Last year, I think there's, 22 kilograms?
Yeah, 22 kilograms.
Collection, and you go from that to 237. That's pretty impressive.
And so if the rate is the same, next year someone's going to pick up 2 tons.
Yeah,
That's
absolutely.
Guys, how much did you all collect?
I believe it was 237, around there. We were expecting to collect about that amount when we were doing our test runs, so we were pretty happy that everything worked out in the end.
When you came in, did you know that at the end of the first day you would be at the top?
Well, we were definitely hoping so. I mean, we had really good practice runs back at home, so we were coming here to really show off what we could do. We're really excited that other teams got quite a bit of material as well. It really pushed us to really get our robot. We stayed up a couple nights really late just to make sure that we could get our run that we thought that we could get. So that was definitely a plus.
This is what you want to do for your livelihood. How rewarding is it to come out here and get so much regolith?
Oh, it's just great. I mean, everyone's here for the same thing, and it's just a beautiful environment in the Luna Pit. You go around when you take a break and you talk to all these different people, and you've all been headed toward the same goal in the end. So it's a really good environment to be in, nice atmosphere.
Do you think you'll be able to remain at the top through tomorrow?
I certainly hope so. But you know what? I wish the best of luck to everybody else. You know what? If somebody does come anywhere near it, I'll definitely shake their hands and congratulate them. Like, this is awesome. Every team has been working on this so hard that they all deserve it.
Well, this concludes our exclusive coverage of the second annual Lunabotics Mining Competition. Let's run through the winners. The Systems Engineering paper winner, John Brown University. Informal or K-12 education winner, Montana School of Mines. Slide presentation winner, Embry-Riddle Daytona. Team Spirit competition winner, University of Alabama, Roll Tide. The Communications Efficiency Award winner, Laurentian University. The Judges Innovation Award winner, Embry-Riddle Prescott. And of course, the On-Site Mining and the Lunarena Awards, starting with third place winner, West Virginia University. Second place winner, University of North Dakota. And of course, first place winner, Laurentian University. And finally, our favorite award, the Joe Cosmo Award for Excellence, the winner, University of North Dakota. Congratulations to all the teams. You did a fantastic job. We look forward to seeing you next year. You're watching NASA Edge, an inside and outside look at all things NASA.